Troubleshooting static routes and GRE tunnels. Static routing is like the duct tape of every network technician. You can accomplish just about anything with it, which is why they ban you from using it when you get to the CCIE exam. It's quick, it's dirty, and it gets the job done, but it's not always the most elegant solution. That being said, they are really useful, and it's rare in the real world that you won't encounter them. So just understanding some key troubleshooting elements is necessary. First off, routers only know about their directly connected networks, right? When I configure this router, give it IP addresses, those are the only networks it knows about. Matter of fact, I just whipped up a quick and dirty GNS3 topology to demonstrate this. I'm going to hop on router 2, do a show IP interface brief, and you can see that I've got two networks it knows about. 10.10.23.0, I put Class C masks, and 10.10.13.0, if I do a show IP route, it says, sure enough, that's the only networks I know how to reach. Well, when I look at this topology, what I've done is I've actually created a loopback interface here on router 3 and given it 10.3.3.3. Matter of fact, let me bring up router 3 and introduce this router to you. Show IP interface brief. You see my fast Ethernet connection over to router 2, but then you also see my loopback interface 10.3.3.3. Okay, so I go over to router 2, go into, let's just get these guys to where I can stagger them a little bit. Do a quick ping 10.3.3.3, negative, not getting there, because it doesn't know how. I'm going to go into global config mode, IP route 10.3.3.3. Let's go direct. 255.255.255.255. Then some people like typing in the next hop interface or the exit interface of the static route. Blah. I don't like doing it. It's not direct enough and it causes problems. I'll explain that in just a second. I'm going to type in 10.10.23.3. Who is that? Router 3. I'm saying to get to that 10.3.3.3 address, use something you know how to get here, to reach something you didn't know. Hit the enter key, ping 10.3.3.3, zing, we go through, right? That's the basics of static routing. Now, the things that can come back and nail you is you and I are like Cisco network guys and gals, right? So when you're sitting on the router, what's its source IP address? This guy, whatever the exit interface, the closest interface to the device or whatever the routing table says it should use when it goes out. So it's going to be, in this case, 192.168.2.2. Well, this router knows how to get to 192.168.2.2, just like in our GNS3 topology. This guy right here, router 3, knows how to get to, what did I say, 10.10.32. I can't remember its IP address, but essentially this guy knows how to get right here, right? So when I ping this, it goes zing, goes right through with one static route. But all of a sudden, when all your hosts sitting beside here decide that they want to get to 10.3.3.3 or whatever address or server is behind there, it's failing. Why? Because it doesn't know, this router doesn't know how to get back to this network. So always remember, static routing is a two-way thing, and get used to, when you're sitting there doing your test, say, okay, well, let's not only ping 10.3.3.3 and get a nice warm fuzzy that's all good. But let's also go in and do a ping 10.3.3.3. We'll do a source, and we'll say, you can type in the IP address or the interface. I'll just do a source of this guy. It comes back and it's like, oh, no. Doesn't know how to get there because I haven't gone over to router 3 and added a static route. Now, static routes, let's use this as the jump off point, can also have default routes as a catch-all, essentially saying send everything to a specific ISP. So, the way we can make that roll is go into router 3 to IP route 0000 0, essentially the least specific mask you can have. And then where do you want to go as your default? In this case, I'm going to say router 2, 10 dot 10 dot 10.10.23.2. It's router 2, right? This guy right here. So now if I hit the up arrow, we saw 5 failures before, I'll do a ping from the same source and zing, goes right through, because this guy is just saying, you know what, it doesn't matter. I'm always sending everything over to router 2, and when I ping from this source address, it's all good, right? That's the core of static routing. Biggest thing you can do wrong, well, I'll cover that in a second. For now, let's talk about GRE, Generic Route Encapsulation. Just think of this as your quick and dirty, just like static routing. That's why I grouped the two topics together. Quick and dirty VPN on the fly. Now, this is not a replacement for quote-unquote VPN technology, because even that term, virtual private network VPN, is ambiguous. There's all kinds of different ways that you can define it. But when most people think of VPNs, they think of I'm installing a VPN client on my laptop, or I've got a site-to-site VPN between my two offices, encrypted over the internet. GRE can play in that world, and you can actually combine encryption and IPsec with GRE, but GRE by itself is just tunneling traffic. So essentially, you've got private networks not reachable on the internet, right? These are RFC 1918 addresses, and you want to tunnel it through a public network. Or, I know some of you are like, I don't get it. Why wouldn't you use a site-to-site IPsec VPN for that? Well, you could and you can, and a lot of people do with GRE. But remember, GRE is just flexible to tunnel anything through anything. That just happened this last week. I was working with a guy setting up an OpenStack data center design. Essentially, it's like your own way of building your own Amazon Web Services, and GRE was one of the fundamental components to where essentially you can have all these different virtual machines, right, where people can have their own little private networks that don't interfere with the corporate network, that doesn't interfere with the OpenStack network. It's crazy how big this gets it, and the whole way that OpenStack did it is by using GRE inside of GRE inside of GRE. I mean, it was weird, it was wacky, but it was a way essentially to have networks inside of other networks that essentially when your customer, I'm so going too far into this, but hopefully it gives you an idea. If you have a customer that comes in and wants to create some virtual machines in your data center, you can actually run them inside of their own little network world that doesn't ever interfere with your parent network or your production network. Anyway, GRE, that's what it's all about, tunneling traffic. So how you make this happen? Really easy. I'm going to go on to router 1, go into global config mode. Let's just do a quick show IP interface brief. I love word wrap. And you can see that fast Ethernet 00's got 5110.11. And then I've got this little loopback simulating this network over here, 10.1.1.1, right? So I'm going to go in and create this new interface that's called a tunnel interface. So I'll say interface tunnel, and you can have 2 billion of these things. Awesome. I'm just going to use tunnel 1, right? From there, I'm going to give an IP address for my tunnel interface, because inside of here, just think of this. We've got this little tunnel going through the internet. Between these two sites, I have this little virtual network. Let's just there's like 5 years in purgatory for doing this, but let's go 192.168.1.1/24. I know some of you are like, what do you mean? You never ever use 192.168 networks on real enterprise Cisco. Anyway, I've done it. My friends have done it, but after so many years, it's like when you get to a network and you see somebody doing 192.168, you're just like, come on. All right, so I'm going to go in and do IP address 192.168.1.1, 255.255.255.0. And then from there, we're going to say the tunnel source is going to be, and this is where we can type in, what interface it's coming from. But I'm going to say the tunnel source is going to be the IP address 5110.1.1, right? Tunnel destination 5110.1.2 over there on router 2, right? Now, same thing over on router 2 side. I'm going to go in, global config mode, interface, tunnel 1. It doesn't have to be the same tunnel interface number, but most of the time it is. And we'll do IP address 192.168.1.2, 255.255.255.0. We'll do tunnel source 5110.1.2, tunnel destination 5110.1.1. That's it. Welcome to generic route encapsulation. You can see line protocol is now up, so I can come over there and I should be able to ping. Let's say I'm on router 2, 5110.1.1. Of course, it's the public internet, right? We know how to get there, and I'm verifying, yes, I can reach that. Okay, but now what about inside of the tunnel interface? Can I ping 192.168.1.1? Bam! I do. So I'm actually encapsulating to get there. How do I know? Show IP route. Going back to our static routing realm, and I can see that I've okay, I use the same routers, don't blame me. But I can see that I have this 192.168.1.0 network that's directly connected. Now, wait a sec. Can I ping 10.1.1.1 over there on the left-hand side? No, I cannot. It's because I have to have a static router, some kind of routing going on with GRE. Okay, ready for reason number 2, besides it's cool, to use GRE? It's the only way you can get dynamic routing protocols over a VPN. Right? If you just do a straight IPsec VPN, it only supports UDP and TCP based traffic, which dynamic routing protocols a lot of times will have their own protocol numbers, or they just won't work over an IPsec VPN. So the way that you do it is you set up GRE, kind of this little base, you set up OSPF, and you're like, hey, router OSPF such and such. Then you do network, and you actually include these guys. It sends hello packets through the tunnel interface, which then you can overlay IPsec on top of that and encrypt the daylights out of that VPN. But I've gone too far. I'm just talking about GRE for right now. So what we're going to do is combine our static routing skill. Do IP route 10.1.1.1. Let's just go 0. Right? Whole network. Oops. 192.168.1.1. I'm careful when I do that because I want to point through the tunnel, so it's using GRE, not to the public interface, because that'll die. And that's why we're doing all this in the first place, is I can't just say, oh, go to the 5110.1.1 over the public internet to reach this private network, because first ISP I get to is like smackdown. You're not going anywhere. So I'll do this same thing on the other side. Exit out, IP route 10.1.2.0. Isn't networking cool? I love I love network. I come home sometimes from a day full of consulting and management, and it feels good to do networking. So I'm going to do a ping 10.1.2.1 over to the other side. Let's just do a trace route. Trace route 10.1.2.1. Exciting, isn't it? But you can see right there, it just goes right through 192.168.1.2. So I see that it's using that tunnel interface on the other side. Finally, since we did an end-to-end, I can actually do a ping 10.1.1.1 from the source of 10.1.1.2, showing true end-to-end, or 10.1.2.1, showing true end-to-end connectivity from router 2's perspective, and sure enough, we're there. Well, now let's hit why we're all here. What can go wrong with static routing in GRE? First off, just common misconfigurations. That's why I put duh. I do this all the time where you're configuring something, you're in spaz mode, you're like, oh, and this, and that, and this, and then it doesn't work. And you're like, oh man, what goes in? And you retrace your steps and you just, mistype something or put it to the wrong direction, whatever. That happens all the time. Second off is static routes pointed to a broadcast interface, proxy ARP of death. That's essentially where you pointed out a broadcast interface like an Ethernet interface. And let me show you what I'm talking about. Normally, and this is how I always do static routes, is I type in IP route, here's my destination, and give it the next hop IP address. Well, you know that you can also go in there and do, whatever. I'll just say IP route 0000, hit the question mark. I could have pointed this just out, fast Ethernet 0/0, right? It'll take that just fine. But what happens is that only works okay if you're on serial point-to-point links. I've seen people do it on fast Ethernet, and initially it seems to work, and that is the failure. Essentially, let me see if I can get a diagram where I've got this going on. So let's just say, I got a nice little white line there. Let's just say that, what am I saying? Let's just say that I've got an internet router right here, right? Just for grins. This goes off to the rest of the cloud. It's, 10.1.55.22, right? Is, well, .1. Make it a little, it's on the wrong subnet altogether. Anyway, you know what I mean, right? You've got a router right here. So instead of pointing to the next hop IP address of that router, you just say, hey, I'm going to point it out fast Ethernet 0/0. Well, what happens then is when this guy says, hey, I got some traffic here, it's going to CNN.com, right? Or, of course, it's not going to say that. It's going to go to the IP address. We'll just say 180.1.1.53, right? Well, this guy's going to get it, and he's like, oh, well, my default route says to send it out fast Ethernet 0/0, so let me just send an ARP message. Hello? Anyone out there know how to get to 180.1.1.53? All the devices get that. This guy, because Cisco routers actually have a feature called proxy ARP on by default, comes back and is like, oh, I can get you there. What's proxy ARP? Proxy ARP is a feature that says, you know what, if you see an ARP message and you look at your routing table, router 5 or 50, because this is 5 up here, router 50, if you look at your routing table and you see that you can possibly get somebody to that route, then why don't you respond to their ARP message and let them know that you can get there? Thus, proxy ARP, right? He's taken the responsibility for that ARP, and it actually works. And that's why in initial testing you're like, dude, this is awesome. I've got, my static route pointed out and everything works. Well, that's all good until you get 10, 50, 100, 1,000 different people that are all trying to surf the web, going to 1,000 different destinations every other minute, right? Now, it doesn't even take that much to swamp the router, but your ARP messages are going crazy. You're essentially causing a broadcast storm over here. This guy's like, trying to respond to all these ARP messages with itself being the destination, essentially just MAC address layer 2, and everything just slows down to a brutal crawl. Because of that, I will always tell you that static routes should be pointed to an IP address. Even on point-to-point links, if you can, point them to the next hop IP address. GRE should be configured with the correct tunnel mode. So tunnel interfaces can be used for all kinds of things. Let me show you. I'm going to bring this guy back up into the picture, do a show IP interface brief. We got tunnel 1. So go into interface tunnel 1. Take a look at this. Tunnel mode. Blah. By default, and everything that we talked about in this nugget is using GRE, Generic Route Encapsulation Protocol. That's the default. But you can see that we can turn on IPsec, for instance, on the tunnel mode. That's how we add IPsec encryption to this and make it a true quote-unquote VPN connection. But there's all kinds of other things you can do. MPLS, IPv6 over IP. This is, by the way, how you can do a lot of the 4 to 6 tunneling, to where you have a router over here that has maybe an IPv4 network on this side, and then you've got your tunnel interface that routes, or actually I should go the other way, IPv6 over here, and then you've got a tunnel interface over a 4 network, and then we've got another IPv6 network over here. You can actually just tunnel that through by using this IPv6 tunnel encapsulation, but in a nutshell, you need to make sure both sides are matching. So if you're going to use GRE or you're going to use MPLS or IPsec, you want to make sure that both sides are matching on the tunnel mode. ACL blocking GRE packets, which is protocol 47. Notice I'm saying protocol, not port number. GRE is a protocol of its own. It doesn't use TCP or UDP. So if you've got a router here, and I've seen a lot of people at the bottom of the router say, you know, permit TCP any, permit UDP any, and they're like, that should allow everything. Well, remember, if you're not typing in permit IP any, you're going to miss non-TCP and UDP based protocols like GRE. So you got to allow protocol number 47 to go through. Routing, I love just crossing my stuff out. Routing protocol enabled on GRE interfaces. You saw in the configuration I just did. As a matter of fact, let me just, right there. On the configuration I just did, you had the outer interface right here and the inner interface. A lot of times people will enable the routing protocol, OSPF or whatever protocol you're using, on the external interface and think the tunnel will take over, where instead you should be enabling, you actually should not enable it on the external because you don't want to send your hello messages out to the world. You want to just enable it on your internal tunnel interface. So don't forget to add that within the tunnel side of it. That's the big picture of what can go wrong. I hope this has been informative for you, and I'd like to thank you for viewing.